So in this question, we are given a reaction that's performed at constant external pressure inside here. And there are some gaseous products. And then there's a water bath and thermometer and some insulation. So this is essentially like a calorimeter, except where volume is not constant, like it might be in a calorimeter. But it's essentially that with the non-constant volume, because the piston can move in and out. So what we find out is two things. We find out that after this reaction, the heat absorbed by the reaction is 153 kilojoules. So heat in chemistry is denoted by the symbol Q, and it flows into the reaction. So in this case, it's plus 153 kilojoules. Note that in thermodynamics, positive and negative tell you direction. Positive means the reaction gains energy, and negative means the energy flows out of the reaction or the reaction loses energy. This is important because of the first law of thermodynamics. Energy can never be created or destroyed. So we have to talk about a specific system because the overall energy change must be zero. So therefore, in this specific system here, in this reaction, it gained 153 kilojoules of energy. The other thing we're given is work, and we found out that from the question that 131 kilojoules of work is done on the system during the surroundings. Work, the symbol is a little more straightforward. It's just W, so heat is Q, work is W, and in this case, it's 131 kilojoules, which is again positive because the work is done on the system. It's quite rare in chemical reactions that I've encountered where the work is about the same order of magnitude as the heat. Usually there's a lot more heat generated or released than work that is done by a chemical reaction. But in this particular case, the magnitude is roughly the same. First question is the reaction exothermic or endothermic? Well, what we want to look at is Q. If Q is positive, it's endothermic. If Q is negative, it's exothermic. Said another way, endothermic reactions are reactions that absorb heat. Q is positive. Exothermic reactions are reactions that release heat. Q is negative. Does the temperature of the water bath go up or down? This is always a challenging question to answer. Keep in mind that the water bath is the surroundings. It is external to the reaction. The reaction is the system which is occurring inside of this piston. If the reaction gains 153 kilojoules of heat, where must that heat energy have come from? It must have come from the surroundings. So the water actually has to get colder. So the temperature of the water bath actually goes down because if the system gains heat, the surroundings must lose heat. Does the piston move in or out? Well, when you're looking at the changes in volume, the piston moving causes a change in the volume. It can go in and decrease the volume or out. In and decrease the volume or out and increase the volume. The change in volume talks about the work term. Work is associated with the change of volume. In fact, work equals negative P delta V, where delta V is the change in volume at constant pressure, in this case 1 atmosphere. We don't actually need to quantitatively calculate it here, but what we can do is notice that the work term is positive. If the work term is positive, work must be done on the system. In order for work to be done on the system, the piston must go in. That's how the surroundings do work on the system. They actually cause this piston to move in, so the surroundings are doing work, the system is gaining work, work is positive for the system, so therefore the piston must move in. Does the reaction absorb or release energy? There are several ways to calculate this, but in the next case, we're actually asked to find the change in energy. So we might as well find the change in energy. Delta E equals Q plus W. In this case, delta E equals Q, which is 153 kilojoules, plus W, which is 131 kilojoules. Delta E equals 284 kilojoules. If delta E is positive, then that means the system absorbs energy. And this also allows us to answer the next question, which is simply 284 kilojoules. So there's a lot going on with thermodynamics, and a lot of the complication comes from defining the system and defining the surroundings. There's only one way to get good at this, which is to do practice. So please practice several problems like this to make sure you're on top of what's the difference between Q and W? What happens when Q is positive? What happens when Q is negative? What happens when W is positive and W is negative? So that you have a better understanding of how the numerical values relate to what's actually occurring in the reaction.